Good morning. Over the next 20 minutes or so, I'd like to share some of the EnSilica experiences and learnings from our work building custom ICs for our OEM customers. Often these projects start with a very unclear or fuzzy set of requirements, which together we work with the customer to refine into a detailed ASIC specification, and obviously working first-time silicon. So a little bit about me. So I lead engineering at EnSilica, and I tend to get involved with our larger projects. The ideas that I'm going to present over the next 15 minutes or so are around how we define our products. And this is what I do every day. The ideas are really the result of having developed lots of products in many varied markets. You can see the list here, and it's quite a lot. It's long, and it's lots of chips, and many of them have already, they've been in production and they've been end of life. It's quite a lot of products. I've got a bunch of patents to my name. I've got a degree, that was a long time ago. I'm a fellow of the IET and a senior member of IEEE. And if you want to check me out on LinkedIn, there's the link. Okay, so most of our customers are OEMs. They use silicon, but they don't do silicon. The definition of their custom chip is critical. Often at the start of a project, many aspects of what the customer wants, they're unclear. We help the customer to refine that. And we found that taking what we describe as a requirements-driven approach to the specification for a product is key. It solves so many problems. It helps you to track development progress and compliance. It provides clear and unambiguous communication, not just back to the customer, but also within the chip design team. So as we engage with our customers, we've concluded that there are some rules. I recently wrote a white paper on this, which is, you can download it from our website. The link's available on the screen. Well, the 7 rules are there, and this is really the heart of what I'd like to go through over the next 15 minutes. The rules are all obvious when you think about it, but when you're in the middle of that big high-pressure project, they often get forgotten. So let's look at each of them in turn. So rule 1 is don't describe why. It's counterintuitive, but don't describe why the product needs to operate in the way that it does. For the team designing it, that's not relevant. That it's relevant to the system architect and the customer, but for the chip design team that are building the product, it's interesting, but it's not the necessary information. Why the product should operate as you describe it in your ASIC specification is important, but it's not that's not the purpose of the specification. So so don't describe why. The design team don't need to know. They just need to know what the set of functions that need to exist are and how they need to operate, not why they need to be there. So that moves us on to rule 2. Do describe what. The spec, it's the reference point for the product development team. If functionality is not described in the specification, it won't exist in the product. It's that simple. Unspoken functionality might be obvious to you, but you're not designing the chip. And it might be obvious to your customer, but again, they're not designing the chip. The role of the spec is to communicate to that group of people who are designing the product what the product needs to do. So, yeah. Rule 2, describe exactly what you need it to do. Don't leave anything out, and don't put anything in that's unnecessary. Which takes us on to rule 3. So don't describe how. Too often, the tendency is to describe the implementation rather than the functionality. The role of the spec is not to tell the design team how to build the product and what circuits to use and what techniques to follow. It's to describe what the functionality that the product needs to present is. It's on the screen there. That's the schematic for a 555 timer I see. It's really interesting, but it's not the specification. The spec describes the functionality, ideally expressed from the interfaces, so from the pins of the chip. And rule 4, so make everything precise and concise. Our typical projects have a design team of 20 to 30 people, and the specs run into several hundred pages. If you can't describe a function clearly in a few words or a few paragraphs, either that function needs to be further decomposed, or we didn't really understand what behaviors you wanted from that particular function of the product. So avoid using 500 words where 50 words will do. If a diagram describes it, use a diagram. Which takes us to rule 5. So ideally, everything should be observable. Ultimately, the spec is the description of what the product must do. After the ASIC design process is completed and your chip's manufactured, you're going to have an activity. You'll be in the lab. You'll be making tests and doing system integration. And it's always easier if you can demonstrate compliance of the product to the spec from direct observations, rather than having to infer that some block in the chip operated in a particular way because something else happened. That's easy to say, but sometimes it's more difficult, and many times you actually need to add functionality in order that you can make things observable. Which takes us to rule 6. Everyone needs to read the specification. It sounds obvious, and you shouldn't need to state it, but we've all heard stories where the customer didn't, you built the product, but it didn't quite do what the customer wanted it to do. It did exactly what the specifications said it should do, but the customer hadn't read the spec, or they hadn't read some section, or they hadn't fully understood precisely what that spec said the product needs to do. And it's not just the customer, it's the design team as well. So a typical product, it's got analog, it's got digital, there's hardware, there's software. There's a natural, there's always a natural tendency for the people in one discipline, so the analog group, to not read the digital functionality, and the digital group to not read the analog functionality. The software team, they're focused on the software. They don't fully read everything to do with the hardware. Everyone in the team needs to read and understand everything in the spec, or at least as far as possible. So that takes us to rule 7. The spec's not the user manual. The audience for the specification is the customer, the end user, and it's the end user with the goal of understanding and agreeing precisely what the product needs to do, not how the product will be used. How it's going to be used is important, and that's key to getting to market. But in terms of defining what the product is, the audience for your specification, it's the customer in terms of defining the functionality, and it's the design team in terms of understanding what functionality is needed. The context of how the product is used is important, but it should be relegated. It should be maintained in a data sheet and in a user manual, not the specification. So if we put this in context, so nobody learning to program would go and look at the language reference manual for whatever language, for C++. You'd go find a book on how to program. As we put together the specifications for our products, that distinction sometimes gets blurred. So the spec's not the user manual. The user manual is the user manual, and there's two very distinct audiences. So those are the 7 rules that we try to follow as we help our customers, who are predominantly OEMs, define exactly what functionality they need from that custom piece of silicon that goes into their product, and how to clearly articulate what those requirements are. And then as we go through the process, the spec's the glue, it holds everything together. As we're going through, how do you build working right first time products? You get the definition right, you do all your prototyping. As you're going through the development process, you stay honest. You track compliance all the way through. So that's compliance of the specification back to the customer requirements. It's compliance of the design in simulation before you've gone to prototyping or gone to a tape out. It's compliance of the system as you do system integration, and then obviously production compliance. So does your silicon on the bench behave exactly as the spec said that it should behave? As you manufacture devices in volume, are the production variations still within the bounds of each parameter that you define in the spec? So those things are easy to say, but in practice they're difficult to do. We've got a really strong focus on quality. We've got a really strong experienced team, and you can see there some of the products that we've developed over the last few years in various different markets. So our markets are, they're automotive, they're safety critical, and they're medical predominantly. But we work in other areas too. There's some further examples of case studies on our website. So that's really what I came to discuss today. So those are some of the ideas that we follow as we define our products. And hopefully you follow all of those ideas too. But if maybe there's some content there that's of interest and new. If anyone's got any questions about how we define our products, how we go about putting together working silicon, then obviously you can message me on this platform, or get in touch on email. My email's on the front slide. Alternatively, if you'd like to talk to EnSilica, if you're one of those OEMs and you're looking for some custom silicon, come talk to us. So there's a contact link on there, and our website gives a full description of EnSilica. Okay, so with that, I'd like to close and thank you.